Okay, this is problem number 11 from the multiple choice, and you were given this f of x, and you had to answer all these different questions about limits and continuity, and so we're going to find the answer by a process of elimination. You have 5 choices. E says that x equals 2 is a vertical asymptote. Vertical asymptotes come from the denominator, and there's no denominator here, so we can easily exclude E as a possible answer. Okay, so since it's all about continuity, I would say go through the steps of continuity. So the question is all happening at x equals 2. So in order to be continuous, f of 2 must exist. So f of 2 would be this, which just gives you 0. So therefore f of 2 does exist. And now we're going to do the limit as x approaches 2 from the left side. So what you have to consider is that you're substituting into this function. If you're less than 2, you're, for example, like 1.9. If you put 1.9 into this x, or really for that matter, anything smaller than 2, the inside of this thing will be negative. But the negative of that will become positive because it's absolute value. So, for example, let's say that you want to say as x approaches 2 from the left side, and we'll use 1.99. You would get this. Okay, and so you're going to get a negative 0.01, but it's an absolute value, so that's going to become a positive 0.01. So it would be absolute value of 0.01. Okay, now think about it. If you do the limit as x approaches 2 from the right side, then you're going to need a number that's going to be bigger than 2, so let's say 2.1. If you put 2.1 in there, then you're going to get the absolute value of 0.1, which is just 0.1, so you're going to get a square root of 0.1. So the limit from the left and the limit from the right does exist. Okay, but here's the thing, that I think this was a trick to try to get you all caught up in the absolute value, because the fact of the matter is, I'm going to just do some erasing here, that when we're going to find the limit of anything, don't we always try substitution as the first thing to try? So here's my function. And can I substitute 2 into there? Yes, I can. And 2 minus 2 is 0, and I'm just going to get 0. The absolute value of 0 is 0. That's the same thing from the left or the right side. We always try substitution first, and we'll get 0. So therefore, the limit is 0, so the limit does exist. If you look at choice D, it says the limit does not equal 0. Well, yes, it does, so D is out. Because f of 2 is equal to the limit as x approaches 2, that means it is continuous. So choice C says f is not continuous. But it is continuous, so that's not true. Okay, then for A, it's saying it's continuous but not differentiable, and for B, it's saying that it is differentiable. Well, this function, is this function continuous? Yes, it is. So it's continuous, but not differentiable, or is it differentiable? Well, it's definitely continuous, so therefore the answer is going to have to be A. So the question is, why would it not be differentiable at x equals 2? Well, the function of the square root looks like this. And if it's an x minus 2, that means that instead of starting at 0, it just starts at 2, like that. Well, it's not going to be differentiable right here at this point, because the tangent line to the curve there would be a vertical line, and there is no such thing as a slope of a vertical line. So therefore, the answer is A. And I would just say that if you were confused by that and you have to choose between A and B, you're not sure about the differentiability, you definitely know it's continuous, so therefore you'd have to go with A. Okay, so that finishes number 11. Okay, so for number 12, This is actually a use substitution problem, but they told you in advance what to use as u. And as I'm looking at my notes, I think I might have said that for this problem the answer was C, but actually it's B. So if you got B, then just move on. You don't have to pay attention to this. But anyhow, so they're telling you that u should be square root of x, which we know is the same thing as x to the 1/2. So if you take the derivative, you're going to get 1/2 x to the negative 1/2 dx. If we simplify that, you're going to get this. Okay, so if you compare that to the original, the only you have a square root of x in the denominator, but you don't have a 2. So you want to get rid of that 2 by multiplying both sides by 2. And when you do that, you'll get this. Okay, and now it's going to match perfectly. So you're going to go back, rewrite the integral. We're going to take out a 1 over radical x dx and change that to do 2 du. And now you're just left with e to the x, e to the radical x, but radical x is just u. So you'd end up with that. And if you look at choice B, it's the exact same thing. So looking at the multiple choices, I mean, some of them, they have some crazy limits. You know the limits are always the same. It's going to go from 1 to 4. So anything that wasn't from 1 to 4 you could have eliminated right away. Okay, so the answer for that was B. Okay, this is number 13. So all you have to do is find the integral from 1 to 5. The problem is that you don't know what the function is, so how would you possibly solve that? Well, you couldn't. However, you do know what the function is from 1 to 3, because you're told that when x is less than 3, 2 is the function. So what if instead of going from 1 to 5, you broke it up like this? Right, because then this whole thing is just really going from 1 to 5, but you're breaking it up by going from 1 to 3 and then from 3 to 5. Well, the integral from 1 to 3 would mean that you're using the function right here, because it's less than 3, so you're just going to get 2 dx. And then the function from 3 to 5 means that you're bigger than 5, so you're going to use this function right here. Okay, so now you're just going to find the antiderivatives of this. So the antiderivative of 2 is 2x, as it goes from 1 to 3. And the antiderivative of x minus 1 is going to be x to the 2 over 2 minus x as it goes from 3 to 5. Okay, so let's first deal with this one right here. So first we'll put 3 in there. 2 times 3 is 6, and then we're going to subtract what happens when we put 1 in there. Well, 2 times 1 is 2. So that's from the first part. Okay, now we'll go to the next part. We're going to do this one right here. Okay, when you put 5 in there, you're going to get 5 squared, which is 25 over 2, minus 5. So that's what happens when you put 5 in there, minus, now we're going to put 3 in there. So you're going to get 9 over 2 minus 3. Okay, so this is from the second integral. I'm just going to do some erasing to make some space. Since we already got that part. Okay, so 6 minus 2 is 4. 25 over 2 is 12 and a half. 12 and a half minus 5 is 7 and a half. And 9 over 2 is 4 and a half. 4 and a half minus 3 is 1 and a half. 7.5 minus 1.5 is just 6, and 4 plus 6 is 10, and that was choice D. Okay, number 14 is not tricky if you remember your compositions of functions from algebra. So you're given f of x and g of x, and you need to find f of g of x. Okay, but you know that g of x is 3x minus 2. So you really want f of 3x minus 2. So that just means wherever you see an x, you're going to replace it with 3x minus 2. Okay, so all I did was replace this x here with 3x minus 2. Okay, and now you're just going to have to do the algebra. So if you expand this, you'll get this. And if you multiply it out, and then you're going to see that those 4's are going to cancel. Isn't that nice? Okay, so that is f of g of x, and you're being asked to find the derivative of that. Okay, so that is really the same thing as this. Okay, so the goal is to find the derivative of this. Okay, so this is just going to be a chain rule. Bring down the 1/2, keep the inside. 1/2 minus 1 is a negative 1/2, and then you need the derivative of the inside. Okay, and then, so that's the derivative, and now you're being asked to find the derivative when x is 3. So all you have to do now is put 3 wherever you see an x. Okay, and then you just have to work out this math, so I'm going to erase a little bit of this to make some room. Okay, so you have 1/2. 9 times 9 is 81. 12 times 3 is 36, and this is all to the negative 1/2. And 54 minus 12 is 42. So we can easily take care of these two pieces. 1/2 times 42. It's just half of 42, so that's going to give you 21. And on the bottom, you're going to have the square root of 81 minus 36. And 81 minus 36 is 45. Okay, and that is not a choice, so we're going to have to reduce that radical 45. And we can do that by breaking that into two radicals, 9 and 5. And we get that. But 3 goes into 21 evenly, so we're going to end up with 7 radical 5, and that was choice A.